And we can define subtraction the same way we did with the integers, a over b and c over d as rational numbers. Then a over b minus c over d is just the unique rational number e over f, so that when we add it to c over d, we get a over b. So again, thinking of this as a over b minus c over d equal to e over f. That's the difference. We can also think about the same property we had with subtraction of integers, in that subtraction is just adding the negative of the other value. So a over b minus c over d is equal to a over b plus negative c over d. And subtraction of rational numbers, we can formulate similarly to how we did addition with different denominators, and say that a over b minus c over d is just a over ad minus bc over bd. All right, so if we want to find these differences, I always like to go back to figures. So if I want to subtract 1/4 from 5/8, I might start by drawing 5/8. So I have 5/8 shaded here. And if I want to subtract 1/4, I could think about my circle in fourths and just take away 1/4. And that leaves me with 1, 2, 3 pieces of size 1/8 or 3/8. You could do this algebraically too by just switching 1/4 into 2/8 by multiplying the numerator and denominator both by 2. If I wanted to subtract 2 3/4 from 5 1/3, I could first convert them to improper fractions and find a common denominator and then proceed that way. Or I could think about subtracting the whole numbers first. So I like to think of it as if I have 5 1/3, so I have 5 wholes and 1/3, and I'm subtracting 2 3/4. So I could say, all right, goodbye, 2 wholes, and then I need to take away 3/4. I could even take away 3/4 from one of my wholes, and so I'm left with 2 1/4 and 1/3. Then I would need to have a common denominator. I could even find the common denominator in my figure by splitting these two circles into 12ths. And seeing that I have 4 12ths and 3 12ths to add together, so I'd have 2 7 12ths. Or like I said, we could first make these mixed numbers improper fractions. So 5 1/3 is 16/3, 2 3/4 is 11/4, and then get that common denominator or use that formula. The common denominator is going to be 12. So 16 times 4 minus 11 times 3 over 3/4, or 3 over 4, excuse me, 3 times 4 would leave me with 64 minus 33 over 12, or 31 over 12, which is the same as 2 and 7/12. I personally think the way I did it makes more sense, but this is using that formula, if you prefer. So we can also add and subtract if we don't have real numbers, if we have variables. So if I have x over 2 plus x over 3, I would need to get a common denominator of 6. So I could say x times 3 over 2 times 3 plus x times 2 over 3 times 2. That would give me 3x plus 2x over 6, and then I can combine my x's to get 5x over 6. And then for 1 over x minus 1 over 2x squared, my common denominator is actually going to be 2x squared, because I can just multiply 1 over x times 2x on the numerator and denominator. And that leaves me with 2x over 2x squared minus 1 over 2x squared, or 2x minus 1 over 2x squared.